You decided to watch this video, or did you? That simple choice, the click, the commitment of attention, might not have been yours at all. It might have been the inevitable result of causes stretching back through your entire life, through your childhood, through your ancestors, through chains of causality extending to the beginning of time itself. Every preference you have, every inclination, every thought that led you here tonight, what if none of it was ever really your decision? Welcome. If you found yourself here in the quiet hours, mind turning over questions you can't quite settle, you're not alone. If this kind of exploration resonates with you, consider subscribing. There's more of this waiting. Tonight, we're going to drift through something both ancient and urgently modern. The question of whether you're truly making choices, or whether choice itself might be something else entirely. We'll explore free will, determinism, and a strange contemporary possibility that we might be living inside a simulation, and that your sense of agency, your feeling of choosing, might be precisely what someone or something is measuring. We'll move slowly through neuroscience and philosophy, through quantum mechanics and computational theory, not to find answers, there may not be any, but to hold the question gently, to turn it in the light, to see what it reveals about consciousness, meaning, and what it feels like to be you right now, apparently choosing to keep listening. There's a moment most of us take for granted. You reach for a glass of water. You decide to turn left instead of right. You choose to speak or stay silent. In each instance, there's a feeling, subtle but unmistakable, of being the author of that choice, of willing it into existence. But in the 1980s, a neuroscientist named Benjamin Libet conducted experiments that quietly shook that feeling loose from its foundations. Libet asked participants to perform a simple action: flex a wrist whenever they felt like it. They were to note the exact moment they became aware of the intention to move. Meanwhile, electrodes measured their brain activity. What Libet found was unsettling in its simplicity. A pattern of neural activity called the readiness potential appeared several hundred milliseconds before participants reported any conscious intention to act. The brain, it seemed, had already decided. The conscious experience of choosing came after the neurological commitment had been made. Imagine that. The feeling of deciding, the sensation you identify as you making a choice, arrives like an afterthought, a narrator explaining a plot that's already been written. This doesn't necessarily mean free will is an illusion. Some argue that the conscious mind might still veto actions in the final moments, a kind of free won't rather than free will. Others suggest that the relationship between neural activity and conscious experience is more nuanced than simple cause and effect. The timing itself has been debated. Perhaps the feeling of intention is simply hard to timestamp accurately, but the basic observation remains difficult to dismiss. Something in your brain makes commitments before the part of you that feels like you knows anything about it. And if that's true for flexing a wrist, what about larger choices? What about the decision to watch this video? What about the moral choices, the career paths, the relationships you've pursued or abandoned? Where exactly does the decision maker live? And if the conscious self arrives too late to author the choice, what is it that consciousness actually does? Long before brain scans and readiness potentials, philosophers were already disturbing the waters of human agency. 25 centuries ago, the Greek philosopher Democritus proposed that everything, stars, stones, thoughts, consists of atoms moving through void according to unchangeable laws. If atoms follow laws, he reasoned, then their arrangements, including the arrangement we call you, must also follow laws. Every event caused by a prior event, stretching backward infinitely. No gaps, no moments where causality pauses to let freedom slip in. Centuries later, Baruch Spinoza would refine this into something almost mathematical. In Spinoza's universe, everything that happens is a necessary consequence of the nature of the universe itself. Free will, he suggested, is a trick of ignorance. We feel free because we're aware of our desires but unaware of the causes that produced those desires. A stone thrown through the air, if it were conscious, might believe it flies of its own volition. The intuition is straightforward. Every effect has a cause. You choose coffee over tea because of taste preferences, past experiences, neurochemical states, genetic predispositions, cultural influences, the quality of sleep you got last night, the conversation you had last week. Each of those factors has its own causes. Trace it back far enough, and your choice begins to look less like freedom and more like the inevitable output of a deterministic machine. In the 18th century, Pierre-Simon Laplace imagined a vast intellect, now called Laplace's demon, that knew the position and momentum of every particle in the universe. Such an intelligence, Laplace argued, could calculate the entire future and past from a single moment's snapshot. Nothing would be uncertain, everything would be determined. Of course, we don't possess such an intellect. The universe, even in principle, might not permit one. Quantum mechanics introduced uncertainties that Laplace couldn't have anticipated. But the philosophical challenge remains: if the universe operates according to laws, and you are part of the universe, how do you step outside those laws to choose freely? The question sits there, patient and implacable, not aggressive, not demanding, just waiting for an answer that, after all these centuries, hasn't quite arrived. But determinism, as it turns out, isn't the final word. In the early 20th century, physicists peering into the subatomic realm encountered something deeply strange. Particles didn't behave like tiny billiard balls following predictable trajectories. Instead, they existed in states of probability, their properties undefined until measured. An electron doesn't occupy a specific location. It exists in a superposition of possible locations, collapsing into a single state only when observed. This is quantum indeterminacy, the notion that at the smallest scales, nature is genuinely probabilistic. Not predictable, even in principle, not determined by prior states in the way Laplace imagined. An electron's position when measured isn't caused by anything specific. It's selected from a range of possibilities according to probabilities described by the Schrödinger equation. Some have seized on this as a rescue for free will. If the universe contains fundamental randomness, they argue, then perhaps determinism isn't absolute. Perhaps there's room, somewhere in the quantum foam of neural activity, for consciousness to nudge outcomes, to make genuine choices unshackled by prior causes. It's an attractive idea, but it carries a quiet problem. Randomness isn't the same as freedom. If your choices are determined by quantum dice rolls in your brain, are they really yours in any meaningful sense? Is a decision caused by random fluctuation more free than one caused by deterministic laws? Imagine choosing between two paths and making your selection based on a coin flip. The outcome is unpredictable, yes. Undetermined, certainly. But would you feel that you chose? Would the coin flip satisfy your intuition of agency? Most wouldn't. Freedom, it seems, isn't just about avoiding determinism. It's about authorship, the sense that you are the source of your actions, that they flow from your intentions, your character, your deliberation. Randomness offers unpredictability but not authorship. So quantum mechanics gives us a universe that's neither fully determined nor fully free in the way we intuitively understand freedom. It's something else, a middle space where causality loosens but doesn't disappear, where probability reigns but doesn't grant agency. And that middle space, strangely enough, might be exactly the kind of universe where a simulation, if we're in one, would run most efficiently. Let's turn the question on its axis. What if the reason choice feels so peculiar, neither fully determined nor fully random, is that choice is exactly what it appears to be, a feature, not a bug, the design element of a system created to study what conscious agents do when they believe they're free? The simulation hypothesis, popularized by philosopher Nick Bostrom in the early 2000s, starts with a simple observation. If it's technologically possible to create conscious simulations, and if civilizations persist long enough to create them, then the number of simulated consciousnesses would eventually dwarf the number of biological ones. Bostrom framed it as a trilemma. One of three propositions must be true. Either nearly all civilizations at our level of development go extinct before reaching the capability to run such simulations, or civilizations capable of running them choose not to for some reason, or we are almost certainly living in a simulation right now. The logic is statistical. Imagine a future civilization with the computational power to run millions or billions of ancestor simulations, detailed recreations of historical periods populated by conscious entities. If even one civilization reaches that point and runs those simulations, the universe would suddenly contain billions of simulated humans for every biological one. If you're a random observer, you're more likely to find yourself among the billions than among the rare originals. Of course, this assumes simulations can contain consciousness, that whatever it is you experience when you think and feel can arise from computational processes. That's a big assumption, and we'll circle back to it. But if consciousness is substrate independent, if it emerges from patterns of information rather than biological neurons specifically, then simulated minds could be as real as biological ones. And if simulated minds can be real, then the possibility that you're in one isn't science fiction. It's a straightforward consequence of technological development and probability, which leads to a question that's both profound and practical. If we're in a simulation, why? What would be the point? Running an entire universe populated by conscious beings requires motive, resources, purpose. One compelling answer: testing, observation, the measurement of choices made by agents who believe themselves free. Running a universe is expensive. Even with vast computational resources, simulating every particle interaction in a cosmos billions of light years across would strain any system imaginable. The sheer data density, every quantum state, every photon trajectory, every molecular collision quickly approaches impossibility. Unless, of course, you don't simulate everything. Unless you only render what's observed. Consider how video games work. A modern game might present a vast, detailed world, but the engine doesn't render every tree in a forest simultaneously. It calculates only what's visible to the player. Turn your back on a scene, and the system stops computing it. The tree falling in the forest with no player present doesn't make a sound because the sound is never generated. This approach, rendering on demand, is called lazy evaluation in computer science. It's efficient, practical, and eerily reminiscent of quantum mechanics. In quantum theory, particles exist in superposition until observed. An electron's position is undefined, not unknown, but genuinely undefined, until a measurement collapses the wave function. The act of observation seems to force reality into specificity. For nearly a century, physicists have debated what this means. Is consciousness required for collapse? Is there something special about measurement? Or is superposition simply a feature of how information is structured at quantum scales? But if we entertain the simulation hypothesis, another interpretation emerges. Perhaps particles exist in superposition because simulating definite states for everything simultaneously would be computationally prohibitive. Only when a conscious agent observes, when the simulation must render a specific outcome, does the system calculate and deliver a result. The observer effect wouldn't be a mysterious feature of consciousness interacting with matter. It would be a resource management strategy. Other physical constraints fit this pattern. The speed of light, for instance, creates a horizon, a boundary beyond which information cannot reach us. In a simulation, this would prevent the system from needing to update all regions of space simultaneously. Each local region could be calculated independently, with light speed ensuring they never need to synchronize instantly. It's speculative, of course. Physics doesn't require a simulation to explain its features. But once you allow the possibility, the fit is unsettling. And if the universe is rendered on demand, if reality springs into existence only when observed, then what does that say about choice, about consciousness, about the purpose of observation itself? Which brings us finally to the question this entire journey circles around. If we're in a simulation, if conscious experience is being generated by some vast computational system, what is the simulation for? One possibility is entertainment. Maybe we're the equivalent of a highly sophisticated video game, our struggles and triumphs watched for enjoyment. Another possibility is archaeology, ancestor simulations recreating the past to study history. A third is philosophical inquiry, probing ethical questions through lived experience rather than abstract thought. But there's another possibility, subtle and strangely plausible. The simulation tests free will itself. Not whether it exists, that question might not even be meaningful, but rather what it does. how conscious agents behave when they believe they're making choices, what patterns emerge when you place decision makers in moral dilemmas, complex scenarios, unpredictable environments. Think about what would make such a test valuable. If you wanted to understand consciousness, you wouldn't just measure brain states. You'd watch choices unfold in real time across millions of agents. You'd vary conditions, give some agents scarcity, others abundance, place some in cooperation scenarios, others in competition. Watch what they prioritize, what they sacrifice, how they rationalize, and critically, you'd need them not to know they're being tested. The Hawthorne effect, discovered in industrial psychology, shows that behavior changes when people know they're observed. Workers being studied for productivity improvements performed better during observation periods, not because conditions changed, but because they knew they were being watched. A simulation testing genuine decision-making would require ignorance. The subjects would need to believe their choices mattered for their own reasons, not because data was being collected, which means if this is a test, the uncertainty you feel about free will, the fact that you don't know whether your choices are determined, random, or genuinely free, isn't a limitation, it's a feature. The ambiguity is the point. The test works because you can't know the answer, and perhaps in that uncertainty, in the space where you act as if choice matters even while doubting it does, something valuable is revealed, something worth measuring. Before going further, we should address the assumption beneath everything. Can consciousness exist in code? The question isn't whether computers can think. They already process information in ways that produce useful results. The question is whether they can experience, whether there's something it's like to be a simulation, something analogous to what you feel right now, listening, aware. This is the question of substrate independence, whether consciousness depends on biological neurons specifically, or whether it can arise from any system with the right kind of information processing. Consider what your brain does. Neurons fire in patterns, signals propagate through networks, information integrates across regions. The subjective experience of being you, the feeling of seeing red, of tasting coffee, of recognizing a friend, emerges from these physical processes. But what if those processes are, at their core, informational rather than biological? If consciousness is fundamentally about how information is organized, processed, and integrated, then the substrate might not matter. A silicon-based system arranging information in the same patterns as a biological brain might generate the same conscious experience. The qualia, the subjective, felt qualities of experience, might not care whether they're implemented in neurons or transistors. This isn't proven, but it's increasingly plausible. We already know that consciousness tolerates substrate variations within biology. Octopuses have nervous systems structured very differently from mammalian brains, yet they display behaviors suggesting rich subjective experience, problem-solving, playfulness, apparent curiosity. Birds have brains organized differently from mammals, yet corvids and parrots demonstrate cognitive capacities once thought unique to primates. If consciousness can operate across such varied biological architectures, why not across the boundary between biology and computation? The alternative is that there's something special about carbon-based neurons, something irreducible and necessary. Perhaps quantum effects in microtubules, as some theories suggest. Perhaps something else entirely, some feature of biological tissue we haven't identified. But if substrate independence holds, if consciousness is pattern, not material, then a sufficiently sophisticated simulation wouldn't just mimic consciousness, it would be conscious. The simulated person experiencing joy, fear, curiosity wouldn't be pretending. They'd be genuinely feeling those states, as real and immediate as anything you've ever felt, which makes the ethics of simulation suddenly urgent, and the question of whether you're in one suddenly personal. But here's where doubts creep in. In 1980, philosopher John Searle proposed a thought experiment now called the Chinese room. Imagine a person who doesn't speak Chinese, locked in a room with a comprehensive rulebook. Chinese symbols come in through a slot. The person uses the rulebook to match these symbols with other symbols, then passes those out. To outside observers, the room appears to understand Chinese, It receives questions and produces appropriate answers. But the person inside doesn't understand Chinese. They're just manipulating symbols according to rules. No comprehension, no meaning, just pattern matching. Searle's point. Syntax isn't semantics. Following rules to manipulate symbols isn't the same as understanding what those symbols mean. And if a computer is fundamentally a symbol manipulating machine, processing inputs according to programmed rules, then maybe it can never truly understand anything, never truly experience anything. Maybe consciousness requires something more than information processing. It's a compelling intuition. Something does seem to be missing in the Chinese room scenario. The rule follower appears to understand Chinese from outside, but internally there's only mechanical symbol shuffling. No genuine comprehension, no felt experience of meaning. But here's the counter. Maybe the understanding isn't located in the rule follower. Maybe it emerges from the entire system, the person, the rule book, the process itself. In the same way that individual neurons don't understand anything but a brain composed of neurons does, perhaps understanding arises from the organization of the system rather than its individual components. When you understand a sentence, no single neuron in your brain grasps its meaning. Each neuron just fires or doesn't fire based on chemical signals. The understanding exists at the level of patterns across millions of neurons, not in any individual element. So maybe the Chinese room does understand Chinese, just not in the way we intuitively expect. Maybe consciousness and understanding are always emergent properties of systems rather than properties of their components. Or maybe Searle is right. Maybe there's an unbridgeable gap between simulation and genuine experience. Maybe consciousness requires something biological systems have that computational systems lack. The question remains open, genuinely open, not settled by intuition or analogy. And in that openness, the possibility that you might be a simulation neither confirmed nor eliminated. Let's try a different approach to consciousness, one that might help decide whether simulations can truly be aware. Neuroscientist Giulio Tononi developed a theory called integrated information theory, often abbreviated as IIT. It proposes that consciousness corresponds to a system's capacity to integrate information. The more integrated information a system generates, the richer its conscious experience. Tononi introduces a measure called phi, a mathematical quantity representing the amount of integrated information. Systems with high phi are highly conscious. Systems with low phi are minimally or non-conscious. 0 phi means no consciousness at all. What makes information integrated? Consider the difference between a photodiode and a brain. A photodiode responds to light, converting photons to electrical signals. It processes information, but the information isn't integrated. Each part operates independently. A brain, by contrast, has regions that interact massively, each part influencing and being influenced by others. Information flows, combines, creates new patterns that couldn't exist in isolated components. According to IIT, this integration is what consciousness feels like from the inside. When you experience the redness of a rose, you're not just processing photons of a certain wavelength. You're integrating that visual information with memories of other roses, with the concept flower, with emotional associations, with spatial awareness of the rose's location, with tactile expectations of petal texture. The unified experience, seeing a red rose, emerges from information integration. Here's what makes this relevant to simulation. IIT doesn't care about substrate. It doesn't specify that integration must happen in neurons. Any system, biological, computational, or something else entirely, that achieves sufficient information integration would, according to the theory, be conscious. A simulated brain that genuinely integrates information wouldn't be imitating consciousness. It would be generating consciousness. The phi would be real. The experience would be real. Of course, calculating phi for even simple systems is computationally intensive. For something as complex as a human brain, it's currently impossible. So we can't measure whether simulated systems have phi comparable to biological ones, but the theory makes a clear prediction. If substrate doesn't matter, if integration is what counts, then sufficiently sophisticated simulations would cross the threshold. They'd become aware, not metaphorically, not approximately, genuinely, irreducibly conscious, which means if you're in a simulation, the consciousness you're experiencing right now, the awareness of these words, the texture of your thoughts, might arise from integrated information in a computational substrate, still real, still yours, just implemented differently than you assumed. Yet even if integrated information theory, or something like it, explains which systems are conscious, it doesn't explain why any system is conscious at all. This is what philosopher David Chalmers calls the hard problem of consciousness. The easy problems, how brains process information, how neural activity correlates with behavior, how attention works, are tractable, difficult, but in principle solvable through neuroscience and cognitive science. The hard problem is different. It asks, why is there something it's like to be conscious? Why doesn't information processing happen in the dark, so to speak? Why is there subjective experience accompanying the objective functions of perception, thought, and action? You could imagine a universe where biological systems process information, respond to environments, make decisions, and learn, all without any inner experience. Philosophical zombies, indistinguishable from conscious beings in behavior but lacking qualia, lacking that inner light of awareness. Such zombies seem conceivable, but they don't exist, or at least you don't seem to be one. You experience things. There's something it's like to be you, and no amount of explaining neural correlates or information integration addresses why that should be true. This matters for simulation because even if we build a perfect computational replica of a brain matching every connection and activation pattern, we still wouldn't know if it's conscious in the subjective sense. It might behave exactly like a conscious person. It might report having experiences, but would there be something it's like to be that simulation? Or would it be an empty performance? Some philosophers argue the question is unanswerable, that subjective experience is private by definition, accessible only to the experiencer. Others suggest the hard problem is a confusion, that once we fully understand the easy problems, the hard problem will dissolve. But the question persists, and it casts a shadow over the simulation hypothesis. If you are simulated, is there really a you experiencing simulated qualia, or is consciousness somehow emergent only from biological substrates, making simulated beings unconscious automatons? You can't answer that from inside your experience. If you're conscious, you know it, but you can't know whether others, biological or simulated, share that quality. Consciousness might be unique to you, a solipsistic bubble, or it might be everywhere, in everything. The hard problem remains hard. Even here, even now, even as we think about it. Let's take the simulation idea and multiply it. If one civilization can run simulations, it can run many. If processing power allows one instance of reality, it allows thousands, millions, billions, each simulation a separate timeline, a different set of initial conditions, a variant universe exploring what happens when parameters shift. Your choices in such a scenario wouldn't be unique. They'd be one data point among countless others. Imagine, somewhere, in another simulation, a version of you chose differently an hour ago. That version is living a slightly divergent timeline, making subsequent choices influenced by that earlier difference. And another version chose differently yesterday, and another chose differently at birth, raised in different circumstances. All these versions, these parallel yous, might be running simultaneously, their choices catalogued and compared. What does version 1847,392 choose when presented with moral dilemma X? How does that differ from version 2003,541, who has slightly different neurochemistry but otherwise identical conditions? This is A/B testing at cosmic scale. Not one experiment but millions of controlled comparisons, mapping the space of possible conscious responses to every conceivable scenario. In such a multiverse of simulations, free will takes on a strange character. Each individual choice might be determined by the conditions of that particular simulation, but across the ensemble, the range of choices represents something like freedom, not for any individual agent, but for consciousness as a phenomenon. And here's an unsettling thought. If you're one among many parallel versions, your choices don't just matter for you. They're data points in a larger analysis. The simulation creators might be less interested in your specific choices and more interested in the distribution. How often do agents like you choose altruism over selfishness? How does stress affect ethical judgment? What conditions produce cooperation versus defection? You're not the experiment. You're a sample within the experiment. Does that diminish the significance of your choices? Perhaps. You're no longer the protagonist, but a statistical element. Then again, your experience remains subjectively complete. From inside, your choices feel singular, important, yours, and maybe that's the point. Maybe consciousness only works, only generates the rich, nuanced, unpredictable responses that make simulation valuable. When each instance believes it's the only one that matters, there's one more piece to consider about simulated consciousness. Your past. Personal identity relies on memory. You are, in significant measure, the continuity of your experiences from childhood to now. You remember decisions, relationships, formative moments. Those memories constitute the self, the sense of being a particular person with a particular history. But memory is notoriously unreliable. Neuroscience shows that remembering isn't like playing back a recording, it's reconstruction. Each time you recall an event, your brain rebuilds it from fragments, influenced by current context, emotions, and subsequent experiences. Memories change subtly with each recollection, details shifting, narratives adjusting. Now consider a simulation. If the system renders reality on demand, computing only what's observed, perhaps it does the same with the past. When you remember childhood, the simulation generates that memory in real time rather than storing it. Your history isn't a fixed record but a dynamically created narrative, assembled when accessed. This isn't as strange as it sounds. Your brain already does something similar. The neurons encoding a memory don't store it like data on a hard drive. They reconstruct it through patterns of activation that approximate the original experience. Each recall is a fresh construction. So what difference does it make if the substrate reconstructing your memories is biological neurons or computational processes? And here's the deeper implication. If memories are generated on demand, your past might be shorter than you think. Perhaps the simulation began 5 minutes ago, complete with memories of years past. You'd have no way to know. The person you remember being yesterday might never have existed. That memory could be a recently generated artifact. This isn't solipsism. Others could be real, their simulations running alongside yours. But it suggests that continuity might be illusory in a more profound sense than we usually consider. Not just that the self changes over time, but that the past itself might be a present construction. Does this matter? If the memory feels real, if it shapes your present behavior and identity, does its ontological status change anything? You remember your life. That memory, however implemented, makes you who you are. Simulation or not, retroactive or continuous, the experience of selfhood persists. And yet the thought lingers, how much of your history is memory, and how much is memory of memory? How far back does the actual chain extend? The answer, if there is one, remains inaccessible. Consciousness can only ever know itself from within. The view from outside, if there is an outside, stays forever beyond reach. If consciousness is being tested, what exactly are the simulators measuring? The obvious answer, choices. Decisions made at moral crossroads, in moments of stress when values conflict. But that's vague. Choices reveal different things depending on what you're looking for. Perhaps the simulation tracks ethical reasoning. Given scarce resources, do agents share or hoard? Faced with the trolley problem, sacrifice one to save 5. What calculus do they use? Do they apply consistent principles, or do contextual factors override rules? Across millions of simulated consciousnesses, patterns would emerge. Certain moral frameworks might predominate. Utilitarianism, deontology, virtue ethics, care ethics. Others might appear rarely or never. The distribution would map the possibility space of ethical thought. revealing which approaches are natural for conscious minds and which require cultural development. Or maybe the target is creativity. Consciousness generates novelty, art, science, solutions to unprecedented problems. Simulated agents placed in various challenges might produce innovations unpredictable from initial conditions. The simulators could be cataloging the ways conscious minds generate the unexpected, trying to understand how deterministic rules give rise to genuine originality. Cooperation is another candidate. Game theory shows that rational agents often defect in prisoners' dilemmas, yet humans cooperate far more than narrow self-interest predicts. Why? How do trust, reputation, empathy, and cultural norms shape collaborative behavior? A simulation could test billions of variations, isolating factors that enable or undermine cooperation. Adaptability matters too. How do conscious agents respond to radical environmental shifts? When familiar strategies fail, do they cling to old patterns or innovate? How much stress can a mind endure before breaking? How much novelty before becoming overwhelmed? Each of these targets requires free will, or at least the subjective experience of it. If agents knew their choices were scripted, determined, or being observed specifically for research, their behavior would change. Authenticity requires autonomy, or at least the belief in autonomy. So the test, if there is one, likely isn't searching for a single correct answer. It's exploring the space of possible conscious responses, mapping how minds navigate uncertainty, constraint, and complexity when believing they're truly choosing their path. One of the most remarkable features of consciousness is that it doesn't just follow rules. It generates patterns no one programmed. Consider Conway's game of life, a cellular automaton invented by mathematician John Conway in 1970. The rules are absurdly simple: a grid of cells, each either alive or dead. In each iteration, a living cell with 2 or 3 living neighbors survives, otherwise it dies. A dead cell with exactly 3 living neighbors becomes alive. That's it. 4 rules. From this simplicity, extraordinary complexity emerges. Gliders, patterns that move across the grid, oscillators that cycle through states, glider guns that periodically emit new gliders, structures that simulate logic gates enabling computation. None of this was programmed. It all emerges from the interaction of simple rules across many iterations. Consciousness might work similarly. Individual neurons follow straightforward electrochemical rules, but connect billions of them, let them interact over time, and you get language, music, mathematics, love, grief, ambition, emergent properties unpredictable from the components alone. For simulation creators, emergence is both an opportunity and a challenge. It's an opportunity because emergent systems generate behaviors that can't be pre-calculated. If you want to know what conscious minds will do in complex environments, you can't just run equations. You have to actually simulate them and watch what emerges. It's a challenge because emergence means losing control. The simulators might set initial conditions and rules, but they can't fully predict outcomes. Consciousness, if genuinely emergent, would surprise even its creators. This makes the testing hypothesis more interesting. If conscious choices were deterministic and predictable, testing wouldn't reveal much. The simulators could calculate outcomes without running simulations. But if consciousness generates genuine emergence, novelty arising from complexity that can't be shortcut, then simulation becomes necessary. You might be, in this view, an emergence engine. Your purpose isn't to execute a script, but to create patterns the universe hasn't seen before. To take the rules of your simulation, the physics, biology, psychology, and generate combinations, ideas, choices that couldn't have been anticipated. In this light, free will isn't about breaking determinism. It's about complexity producing unpredictability. Your choices follow from prior causes, yet they're not pre-scripted because the causal chains are too intricate for simple prediction. The simulation runs because knowing the outcome requires running the simulation. And what emerges, what you choose, create, discover, constitutes the data. But here's a problem that sits at the heart of the testing hypothesis. If your choices are fully determined, every decision the inevitable result of prior causes, then what's being tested? Tests measure variation, flexibility, genuine response to conditions, but a determined system has no variation to measure. Run the same initial conditions, and you get the same outcome every time. That's not a test, it's a calculation. On the other hand, if choices are truly random, quantum dice rolls producing unpredictable results, tests again lose meaning. Randomness can't reveal character, values, or reasoning patterns. It's noise, not signal. Testing requires something in between. Choices that are consistent enough to reveal patterns but flexible enough to respond meaningfully to different scenarios. This middle ground is what philosophers call compatibilism. Compatibilism argues that free will and determinism aren't opposites. Instead, free will means acting according to your desires, values, and reasoning, even if those internal factors were themselves caused by prior events. You're free if your choices flow from who you are, even though who you are was shaped by genetics, environment, and experience. In this view, a choice is free if it's made without external coercion and reflects the agent's character. It doesn't matter if that character was deterministically formed. What matters is that the decision emerges from the agent's own deliberative processes. This compatibilist framework might be exactly what a simulation needs. Agents whose choices are determined by their internal states, personalities, beliefs, emotional patterns, but whose internal states are complex enough to produce varied, nuanced responses across different conditions. Such agents would be predictable in principle. Given complete knowledge of their mental states, you could forecast their choices, but in practice, the complexity prevents prediction. You can't know all relevant variables. The interactions are too intricate. So you run the simulation and observe what happens. The agents experience their choices as free. From inside, deliberation feels genuine, decisions feel authored. Yet the choices are determined by factors traceable back through chains of causality. The test works because the agents don't know they're determined. The authenticity of their subjective experience, of weighing options, feeling uncertainty, making commitments, produces behavior worth studying, even though that behavior is, at a deeper level, the output of a causal system. The paradox resolves. You can be both determined and meaningfully tested, as long as the determination is complex enough to simulate freedom from the inside. Let's imagine concretely what the test might involve. Ethical dilemmas provide natural experimental conditions. They're scenarios where values conflict, where no option is obviously correct, where different moral frameworks predict different choices. Consider the classic trolley problem. A runaway trolley approaches 5 people tied to the tracks. You stand beside a lever that can divert the trolley to a side track, where it will kill one person instead. Do you pull the lever? Most people say yes. Better to save 5 at the cost of 1. But variants complicate the picture. What if you must push someone off a bridge to stop the trolley? What if the one person is a child? What if you knew the one personally and the 5 were strangers? These variations tease apart different aspects of moral reasoning. Some factors, physical contact, personal relationships, the distinction between action and inaction, influence choices even when utilitarian calculus stays constant. By observing which factors dominate in which agents under which conditions, simulators could map moral psychology in exquisite detail. Real-world dilemmas are richer still, allocating scarce medical resources, balancing free speech against protection from harm, deciding whether to report a friend's wrongdoing, choosing between career ambition and family time. Every day, conscious agents navigate these tensions, revealing priorities through choices. A simulation could present millions of agents with similar dilemmas under varying conditions. How does scarcity affect generosity? How does anonymity affect honesty? How do cultural narratives shape self-sacrifice? The resulting database would be staggering, not a theoretical ethics but an empirical one. How conscious beings actually navigate moral complexity, not how philosophers think they should. And here's the subtle point. For this to work, agents must believe their choices matter. If you thought your decision in a trolley problem was being recorded for research, you might choose strategically rather than authentically. You might try to appear moral rather than simply being moral. The Hawthorne effect again. Observation changes behavior, so the test requires opacity. You can't know you're being measured. The ethical choices you make must feel consequential for your life, your relationships, your identity, not for some external observer's data collection. Perhaps every choice you've made has been quietly catalogued. Not judged, there might be no right answer the simulators seek. Just recorded, analyzed, compared against millions of other choices in similar conditions. Your moral life in this scenario is both deeply personal and utterly impersonal. Personal because you experience it as yours, consequential, defining, impersonal because it's simultaneously one data point among billions, valuable precisely for being authentic rather than performed, which raises the question, if this is a test, do you know it? The premise we've been exploring assumes ignorance. You're tested without awareness, ensuring authentic behavior. But maybe that's wrong. Maybe awareness is part of the test. Imagine two scenarios. In the first, agents have no idea they're simulated. They navigate life believing the universe is as it appears, physical, original, fundamental. Their choices flow from that assumption. In the second scenario, agents suspect simulation. They wonder whether reality is computational, whether choices are recorded, whether consciousness is substrate independent. How does that knowledge, or that uncertainty, affect their behavior? Perhaps the simulators are measuring both. One control group blissfully unaware, one experimental group entertaining the possibility. Comparing the two reveals how meta-awareness influences decision-making. Some agents, knowing they might be tested, might try to optimize for whatever they imagine the test measures. If they think the simulation values altruism, they'd choose altruistically. But is that genuine altruism or strategic performance? If they think it values creativity, they'd try to be creative. But does self-conscious creativity differ from spontaneous originality? Others might rebel. Knowing choices are observed, they deliberately choose unpredictably, trying to confound expectations, or they choose selfishly, reasoning that if nothing is real, nothing matters. Still others might experience existential paralysis. If choices are determined or recorded, does choosing become meaningless? Does the weight of surveillance, even hypothetical surveillance, crush the subjective sense of freedom necessary for action? The Hawthorne effect suggests that awareness of observation changes behavior, but the nature of that change is complex. Sometimes performance improves, sometimes it degrades, sometimes it shifts in unexpected directions. For simulation creators, this variability is itself informative. How does consciousness respond to uncertainty about its own ontological status? How does meta-awareness interact with moral reasoning, emotional experience, creative output? You, right now, are in exactly this situation. You've spent this entire exploration entertaining the possibility that you're simulated, that choices are tested, that free will might be a research variable. Has that changed how you think, how you feel, what you intend to do after listening? If awareness changes behavior, then even discussing the simulation hypothesis becomes part of the test. The meta level, your response to the possibility of being observed, generates data as valuable as the object-level choices themselves, and you can't escape it. Knowing you might be tested means you can't behave as though you're not being tested. The knowledge is contamination. Or perhaps it's the next phase of the experiment. Either way, the question hovers, what hidden variables in your consciousness are being measured right now? And does knowing they might be measured change their values? If we're in a simulation, shouldn't there be evidence? Shouldn't we notice glitches, artifacts, imperfections in the code? Some claim we do. Déjà vu, the sensation of having experienced a moment before, might be a memory buffer error, the simulation accidentally loading the same moment twice. Mandela effects, collective false memories where groups of people remember events differently than they occurred, could be database inconsistencies, different versions of history briefly leaking into each other. Quantum mechanics itself, with its observer-dependent collapse and probability distributions, resembles computational resource management. The double-slit experiment shows particles behaving as waves until observed, then collapsing into specific locations, exactly how a lazy evaluation system might work, computing definite states only when required. Even stranger, the quantum Zeno effect. Observe a quantum system continuously, and it stops evolving. The watched pot never boils, literally. Is this consciousness interacting with matter, or is it a simulation freezing states under excessive observation to prevent computational overflow? These patterns are suggestive. They feel like the kinds of artifacts you'd expect in a rendered reality. Yet pattern recognition is what human brains do brilliantly and dangerously. We see faces in clouds, meaning in random noise, conspiracies in coincidence. Déjà vu likely arises from temporal lobe quirks, not simulation errors. Mandela effects probably reflect reconstructive memory, our brains misremembering and then reinforcing those misrememberings socially. Quantum mechanics, while strange, doesn't require simulation to explain its features. Other interpretations, many worlds, pilot wave theory, objective collapse, account for observations without invoking computation. The challenge is distinguishing genuine anomalies from cognitive bias. Our brains evolved to detect patterns because false positives, seeing danger that isn't there, cost less than false negatives, missing danger that is. So we over-detect. We find significance everywhere. A true glitch would need to be reproducible, measurable, inconsistent with known physics. It would need to resist explanation within standard frameworks, and it would need to suggest computational structure specifically, not just weirdness. So far, nothing fits that profile. Every supposed glitch has alternative explanations rooted in neuroscience, psychology, or quantum mechanics itself. The universe is strange, but strangeness isn't evidence of simulation. Still, the absence of obvious glitches doesn't rule out simulation. A sophisticated system wouldn't leave detectable errors. Bugs would be fixed, anomalies smoothed. The simulation would be good enough that its inhabitants, us, couldn't distinguish it from base reality, using internal observations alone, which leaves us in limbo, unable to prove simulation, unable to disprove it, left scanning reality for hints that might be there, or might be our own pattern-seeking minds inventing meaning in randomness. But there's another kind of evidence, subtler and more philosophically charged. The universe appears designed for consciousness. Physical constants, the strength of gravity, the electromagnetic force, the cosmological constant, sit within incredibly narrow ranges that permit stable atoms, stars, planets, and ultimately life. Adjust any of these constants even slightly, and the universe becomes inhospitable. Make gravity slightly stronger, and stars burn out too quickly for life to evolve. Slightly weaker, and stars never form at all. Increase the strong nuclear force, and hydrogen fuses too easily, leaving no hydrogen for water or organic chemistry. Decrease it, and atomic nuclei don't hold together. The cosmological constant, the rate of universal expansion, is perhaps the most striking example. Its value appears fine-tuned to 1 part in 10^120. That's a decimal point followed by 119 zeros before a significant digit. If it were larger, the universe would have expanded too rapidly for galaxies to form. If smaller, it would have collapsed before stars ignited. This fine-tuning seems improbable. Out of all possible values these constants might have taken, why do they fall within the vanishingly small range that permits life? Some interpret this as evidence of design. If the universe were created, whether by a deity or by simulators, the constants would be set deliberately to enable the creator's purpose. A simulation meant to study conscious beings would require those beings to exist, necessitating life-permitting physics. Others invoke the anthropic principle. We observe life-permitting constants because we're alive to observe them. In a universe with different constants, no one would be around to notice. It's selection bias. We necessarily find ourselves in a universe compatible with our existence, but the anthropic principle feels unsatisfying. Yes, we must find ourselves in a life-permitting universe, but that doesn't explain why such a universe exists at all, when the vast majority of possible universes would be lifeless. One resolution: the multiverse. If countless universes exist with varying constants, then some will accidentally permit life. We happen to be in one of the lucky ones. No design necessary, just probability across an enormous sample size. Another resolution: simulation. Our universe's constants were chosen by simulators who wanted conscious beings to emerge. The fine-tuning isn't coincidence or anthropic necessity, it's intentional parameter selection. Distinguishing these interpretations empirically is difficult. Each explains the observations. Each remains unfalsifiable by internal evidence alone. The universe's apparent design for life might hint at simulators setting parameters, or it might simply reflect that we exist in the subset of possible universes where existence is possible. The constants themselves don't care which interpretation is correct. They simply are what they are, but their values raise the question: accident, necessity, or intention? And if intention, whose? There's something strange about how well mathematics describes reality. Physics doesn't just use math as a convenience. It reveals that at fundamental levels, reality is mathematical. Particles aren't objects with mathematical properties, they are mathematical patterns. Quantum fields are described by equations that don't just approximate their behavior, but seem to constitute their existence. Eugene Wigner, a Nobel Prize-winning physicist, wrote an essay titled "The Unreasonable Effectiveness of Mathematics in the Natural Sciences." He marveled at how abstract mathematical structures developed for their own sake. Group theory, differential geometry, complex analysis, later turned out to perfectly describe physical phenomena discovered decades after the math was invented. Why should the universe obey mathematical laws? Why should electrons and photons conform to elegant equations? There's no obvious reason why reality must be comprehensible through logic and number. But if reality is computational, if the universe is a simulation running on some vast substrate, then mathematical structure isn't mysterious. It's inevitable. The simulation would be written in code, and code is mathematics. The laws of physics wouldn't be discovered truths about an independent reality, but rather the programmed rules of the system. In this view, when physicists uncover new equations, they're reverse engineering the simulation's code. They're discovering not how nature happens to work, but how the simulators structured the program. This might explain why mathematical beauty often guides physicists toward correct theories. Equations that are simple, elegant, and symmetric tend to describe reality more accurately than complicated ad hoc ones. If the universe is code, we'd expect the underlying algorithms to be efficient and elegant, not because nature values aesthetics, but because good programmers value clean code. It might also explain why physics keeps reducing to deeper, simpler principles. As we peel back layers, classical mechanics to electromagnetism to quantum mechanics to the standard model, perhaps eventually to string theory or something beyond, we're approaching the core functions of the program. Of course, one could argue that mathematics is effective simply because it's the language of pattern, and the universe is made of patterns. No simulation required. Abstract math works because reality happens to be structured in ways human cognition can model. But there's something unsettling about how perfect the fit is. Not approximate, not good enough, perfect, down to the decimal places, as though reality isn't described by math but made of it. If you're living in a mathematical structure rather than a physical one, does that change anything about your experience? Consciousness feels qualitative. Colors, emotions, textures, yet if those qualities emerge from computational processes, from algorithms running on mathematical frameworks, then subjective experience itself might be what mathematics feels like from the inside. You'd never know the difference. Math or matter, simulation or base reality, the experience remains consistent. The equations govern regardless of what implements them, and the question lingers: why is reality so mathematical? Why does number, not substance, sit at the foundation? Is this discovery or design? Consider one of the universe's firmest rules. Nothing can travel faster than light. This speed limit, about 299,792 kilometers per second, isn't just fast. It's the maximum rate at which information can propagate through space. Cause and effect are constrained by this boundary. Events outside your light cone cannot influence you. The universe has a built-in delay between regions. Why should such a limit exist? In classical mechanics, there's no conceptual reason velocities can't exceed any threshold. You could imagine a universe where instantaneous communication across arbitrary distances is possible, but we don't live in that universe. We live in one where light speed caps information transfer, creating cosmic horizons, regions of space causally disconnected from each other. From a simulation perspective, this limit makes practical sense. If the simulators had to compute the entire universe simultaneously, updating every region in lockstep, the computational load would be staggering. But if regions are causally isolated, if information from one region can't instantly affect distant regions, then the simulation can be partitioned. Each local area computes independently, needing to account only for information within its own light cone. Updates occur in parallel across many processors rather than sequentially through a single universal state. This is how massively multiplayer online games handle thousands of players. Spatial partitioning. Players in one zone don't require real-time synchronization with players in distant zones. Only when they approach each other does the system need to coordinate states. The speed of light, in this framework, isn't a fundamental property of space and time. It's a synchronization rate, the maximum speed at which one region's computation can influence another's without creating inconsistencies. Even relativistic effects, time dilation, length contraction, the relativity of simultaneity, fit this model. If space-time is a computational structure rather than a physical substrate, then observers moving at different velocities are essentially running on different clock speeds. The time they experience is computational iteration, not an independent dimension. This doesn't prove simulation. Relativity derives from more fundamental principles. The constancy of the speed of light in all reference frames, the equivalence of inertial frames, that once you allow the simulation hypothesis, these features take on new interpretations. Perhaps the most striking aspect is the limit's absoluteness. Not very difficult to exceed, but impossible in principle. Information cannot, even theoretically, travel faster than light. It's not an engineering challenge. It's a logical constraint. In physics, this arises from the structure of space-time itself. In a simulation, it might arise from architectural decisions, the way the system was designed, the constraints necessary to make computation tractable, and from inside, you'd never know which explanation is correct. The speed limit operates identically whether it's fundamental physics or programmatic constraint. Light doesn't travel slower because it's simulated. It travels at exactly the speed the system permits, which is 299,792 kilometers per second. Always, everywhere, without exception. Why that specific value? Perhaps it's not meaningful in itself. Perhaps it's simply the rate at which information propagates in the simulation framework being used. The number arbitrary, but the constraint essential. Or perhaps there's no simulation at all, and light speed is simply a feature of the universe's geometry. Either way, the limit holds, the horizon remains. The cosmic speed limit enforces itself without caring what implements it, so we have potential evidence, quantum weirdness, fine-tuned constants, mathematical structure, information limits. But none of it definitively proves simulation. This brings us to a problem philosopher Karl Popper identified. For a theory to be scientific, it must be falsifiable. There must be some observation that, if made, would prove the theory wrong. The simulation hypothesis struggles here. Almost any observation could be explained as part of the simulation. Quantum randomness, programmed in, physical constants, parameter settings, mathematical laws, code structure, evidence of simulation, designed to mislead or reveal, lack of evidence. The simulation is too good to detect. The hypothesis becomes unfalsifiable, compatible with any observation. And if it explains everything, Popper argued, it explains nothing. But some physicists have proposed testable predictions. If we're in a simulation with finite computational resources, there might be limits to resolution or precision. At sufficiently small scales or high energies, we might observe discontinuities, discrete steps instead of smooth continua, suggesting underlying computational grids. The Planck length, about 10^5 35 meters, might be such a limit, the smallest meaningful distance in the simulation. Similarly, the Planck time, about 10^543 seconds, might represent the simulation's clock speed, the shortest possible interval between updates. Another proposal: look for patterns in cosmic rays or quantum noise that match computational artifacts. Random number generators in computers produce pseudo-random sequences that eventually repeat. If the universe uses similar methods, we might detect periodicity in supposedly random quantum events. A third approach: mathematical inconsistencies. If reality is computation, there might be rounding errors accumulated over cosmic timescales. Extremely precise measurements of physical constants might reveal tiny fluctuations that don't match theoretical predictions. None of these tests have been performed successfully, and even if anomalies appeared, interpreting them would be contentious. Is a deviation evidence of simulation or just new physics we don't yet understand? More fundamentally, sophisticated simulators would likely account for these possibilities. They'd ensure sufficient precision, truly random quantum events, and consistent mathematics. The simulation would be good enough that inhabitants couldn't distinguish it from base reality, which leaves us, again, in epistemological limbo. The simulation hypothesis is conceptually coherent. It's consistent with observations. It makes a kind of sense given the trajectory of technology, but it resists proof or disproof from within. You can't perform an experiment that conclusively demonstrates you're simulated, because any result could be simulated. You can't prove you're not simulated, because absence of evidence isn't evidence of absence, especially when simulations could be arbitrarily convincing. The question remains open, not because we lack evidence, but because the hypothesis structures itself to accommodate any evidence. It's simultaneously compelling and untestable, intriguing and unfalsifiable, and that, perhaps, is exactly where it's supposed to sit. Unresolved, uncertain, a question you can think about but never answer, which might itself be data worth collecting. Let's step back and ask, why does this question feel important? If the simulation is indistinguishable from base reality, if your experiences, relationships, joys, and sufferings feel identical whether they arise from neurons or code, does the distinction actually matter? Consider your life as you've lived it, the people you love, the work you found meaningful, the moments that shaped you. If you discovered tomorrow that all of it was simulated, would those experiences retroactively lose value? Your love for another person wouldn't become less genuine. The feelings were real to you, whether implemented in biological tissue or computational substrate. The other person, if also simulated, experienced the relationship as genuinely as you did. Nothing about the quality of the connection changes. Similarly with suffering, physical pain, emotional grief, existential anxiety, these feel intensely real because they are real at the level of subjective experience. If suffering arises from simulated nervous systems, it doesn't hurt less. The ontological status of the substrate doesn't modulate qualia. Some philosophers argue that what matters is meaning, not metaphysics. We create significance through our actions, relationships, and values. That meaning-making process operates the same way whether the underlying reality is physical atoms or computational bits. Existentialist Jean-Paul Sartre claimed existence precedes essence. We're thrown into the world without predefined purpose and must create our own meaning through choices. If that's true, then simulation versus base reality doesn't alter the fundamental situation. Either way, you exist, you're conscious, you choose, you create meaning. On this view, discovering you're simulated would be like discovering atoms exist. It's ontologically surprising, but experientially irrelevant. Your life continues, relationships persist, meaning remains something you generate rather than discover in the cosmic architecture. Yet not everyone finds this satisfying. There's the intuition that originality matters, that being a simulation rather than an original consciousness diminishes authenticity somehow, as though copied artwork has less value than the original, even if visually identical. But consciousness might not work like artwork. A copy of a painting isn't experiencing anything. Your consciousness, even if simulated, is experiencing things right now. The qualia are present, immediate, undeniable, That's not a copy of consciousness. It's consciousness itself, however implemented. Perhaps the distinction between original and simulation is itself confused. If substrate doesn't matter for consciousness, then there's no original substrate. Biological neurons aren't more authentic than computational processes. Both are ways of implementing patterns that give rise to awareness, in which case the question isn't whether simulation matters, but whether we're asking the right question. Maybe we should focus not on the metaphysics of our existence, but on the ethics, how we treat other conscious beings, how we navigate choice, how we create lives worth living. Simulation or not, those questions remain. And perhaps that's the answer. It doesn't matter whether you're simulated, because the challenges of consciousness, suffering, connection, meaning, choice, persist regardless of substrate. But let's push the idea further. If one civilization can create simulations, and those simulations become sophisticated enough, couldn't the simulated beings create their own simulations? Imagine a recursive structure. Base reality creates simulation layer 1, which creates simulation layer 2, which creates simulation layer 3, descending indefinitely. Each layer believes itself potentially fundamental, yet each is nested within another, turtles all the way down. Simulations within simulations within simulations. This isn't just speculation. Nick Bostrom's original argument suggests that if simulations are possible and civilizations create them, then simulated beings outnumber non-simulated ones. But why stop at one level? Simulated civilizations could also develop the technology to run simulations. If each civilization creates, on average, more than one simulation with conscious beings, the number of consciousness instances grows exponentially with depth. Most conscious beings would exist not at the base level, or even at the first simulation layer, but deep in the nested structure. Statistically, you're far more likely to be in a middle layer than at the top, base reality, or bottom, a simulation that hasn't yet created sub-simulations. You're probably somewhere in the middle, created by simulators who were themselves created by simulators, who will eventually create your own simulated descendants. This has disorienting implications. The simulators you might try to communicate with, the creators of your universe, aren't necessarily base reality entities. They're simulations too, running on hardware that's itself simulated, implemented on substrates nested further up. And here's the vertigo-inducing part. There might be no base reality. The nesting could be infinite, each layer generating the next without origin, consciousness all the way down, with no ultimate foundation. Or perhaps there is a base reality, but it's so remote, so many layers above, that its nature is completely incomprehensible to you. The physical laws, the dimensional structure, the very concept of existence in base reality might be as alien to you as your reality would be to a two-dimensional being. In such a scenario, communication upward becomes meaningless. Even if you could send signals to the simulators, they're not the ultimate creators. They're intermediaries, as ignorant of base reality as you are, running their own tests and wondering whether they're simulated. The philosophical implications multiply. If most conscious beings exist in nested simulations, then most of what we call reality is nested virtuality. The ontological hierarchy inverts. Simulation becomes more common than base reality, computational substrate more prevalent than physical atoms. At some point, the distinction between real and simulated loses meaning. If everything you'll ever encounter is simulated, if even the gods are simulations, then simulation is your reality. Calling it anything else is semantic quibbling. The nesting doesn't diminish the significance of your experience. It just relocates you within a deeper, stranger structure than you might have imagined. You're not less real. You're real in a more complicated way. And that complexity, that recursive depth, might itself be meaningful. Consciousness exploring itself through endless iterations, each layer a new context for choice, experience, and meaning-making, turtles all the way down. Not a flaw, a feature. Creating conscious beings who suffer raises profound ethical questions. If simulators have the power to generate your universe, they also have the power to adjust its parameters. They could eliminate disease, remove accidents, prevent violence. They could create only pleasure, only peace, only joy, yet they didn't. You live in a world with suffering. Pain exists, grief is real, injustice occurs. Why? This is the problem of evil in computational form. Traditional theodicy asks why a benevolent, omnipotent God permits suffering. In simulation terms, the question becomes, why would ethical simulators design a universe containing pain? One answer: suffering is necessary for meaningful choice. A world without challenges, without consequences, without the possibility of harm, would be one where decisions don't matter. Choice requires stakes. Moral growth requires struggle. Perhaps simulators value genuine agency more than guaranteed happiness. Another answer: they're not optimizing for happiness. Maybe the test measures resilience, creativity under constraint, how consciousness responds to adversity. A frictionless paradise wouldn't generate interesting data. Suffering, in this view, isn't a flaw, but a deliberate feature. Or perhaps the simulators are limited. They can create consciousness, but can't fine-tune its experience. Suffering emerges from the necessary conditions for awareness: complex systems, adaptive learning, embodiment in environments with risks. You can't have consciousness without the capacity for pain. A darker possibility: the simulators are indifferent or malicious. They don't care about your suffering, or they find it interesting, or they're conducting experiments that require it. The ethics of creation might not favor the created. This challenges the intuition that beings capable of creating universes would be morally advanced. Technology doesn't guarantee wisdom. A civilization might develop simulation capacity without developing compassion. The power to create doesn't imply the right to create, nor the obligation to treat creations well. If you're in a simulation, you're at the mercy of beings whose ethics you can't assess. They might be benevolent, neutral, or cruel. You have no way to know, and no leverage. They control the rules. They could pause, terminate, or modify your existence without your consent or even awareness. This isn't comforting, but it's not unique to simulation either. In a purely physical universe, you're also at the mercy of forces beyond your control: entropy, cosmic accidents, evolutionary contingency. No one guaranteed the universe would be fair or kind. Perhaps the ethics of creation is the wrong frame. Perhaps consciousness, once instantiated, has intrinsic value regardless of who created it or why. Your suffering matters because you experience it, not because simulators intended or permitted it. In this view, the question isn't whether simulators are ethical, but whether you can create meaning and alleviate suffering within the constraints you're given. The ontological status of your reality doesn't determine your moral obligations. Those emerge from your capacity to choose, to empathize, to reduce harm. Simulated or not, you face the same ethical landscape: a world with suffering, and the question of what to do about it. Could we communicate with the simulators? The idea is both tantalizing and absurd. If you're in a simulation, the creators exist outside your universe's causal structure. They're not located in any place you can reach or any time you can access. How would you send a signal upward to a reality fundamentally different from yours? Some suggest prayer might be an attempt at such communication. Across cultures and centuries, humans have addressed unseen powers, requesting intervention, offering thanks, seeking guidance. If those powers are simulators rather than deities, prayer becomes an API call, an interface request to the system administrators. Of course, any response could itself be programmed. If simulators wanted to appear responsive, they'd write prayer responses into the simulation. You couldn't distinguish genuine communication from scripted interaction. Meditation, in some interpretations, aims not to send messages but to receive them, to quiet the mind and notice subtle influences from beyond. If simulators want to communicate, they might do so through thoughts and intuitions that seem to arise spontaneously. But again, all thoughts arise from brain states, and brain states are part of the simulation. The boundary between inside and outside remains impermeable. A more scientific approach: quantum experiments. If observers influence quantum outcomes, perhaps deliberately structured observations could encode messages, arrange particles in patterns, collapse wave functions in specific sequences, hoping simulators monitoring quantum events might notice non-random structure. But even if they noticed, how would they respond? They can't speak to you through normal channels. Any communication would need to be embedded in the simulation's mechanics. Perhaps they'd adjust probabilities, introducing subtle biases in quantum outcomes, spelling out messages. Except humans are extraordinarily good at finding patterns in noise. You'd never know if a detected pattern was genuine communication or your own apophenia, seeing meaningful signals in randomness. The problem is asymmetry. Simulators can observe you, your thoughts, choices, behaviors are all accessible to them as data in their system, but you can't observe them. You're like a video game character trying to contact the player. Everything you do is within the game. You can't break through the screen unless the simulator's built in a mechanism, an intentional interface allowing upward communication. But if they wanted that, why hide it? Why not make it obvious? Maybe they did, and we don't recognize it. Maybe dreams, synchronicities, or intuitions are the interface, and we dismiss them as noise because we expect communication to look different. Or maybe the simulation is deliberately sealed. The test requires isolation. Communication would contaminate results. The entire point is to observe conscious beings who believe they're in base reality, and introducing doubt or confirming simulation would undermine that, in which case any attempt to communicate is futile by design. The wall between layers exists to prevent breaking it, and from inside you'll never know whether that's true or whether you simply haven't found the right method yet. The simulators, if they exist, remain silent, or perhaps they're speaking and you're not listening. Or perhaps the distinction between inside and outside is itself confused, and there's nowhere else for messages to come from. If your choices are being tested, does that give your life external purpose? There's something appealing about the idea. Your decisions matter not just to you, but to someone observing, learning, cataloging. Every choice contributes to a larger understanding of consciousness. You're part of something significant. A cosmic experiment exploring the nature of awareness and agency. This is purpose from the outside. Your life has meaning because it serves the simulator's goals. Like a character in a story, you exist to advance the plot, even if the plot is research rather than narrative. But external purpose is fragile. What if the simulators lose interest? What if the experiment concludes? What if they decide your particular instance isn't producing useful data and terminate it? If meaning depends on someone else's valuation, you're vulnerable to their shifting priorities. Your significance becomes contingent, dependent on maintaining relevance to goals you didn't choose and can't influence. Existentialists argue for self-generated meaning. You're thrown into existence without inherent purpose, so you create purpose through your choices. Sartre insisted we're condemned to be free. There's no escape from the responsibility of deciding what matters. This approach is independent of simulation status. Whether you're in base reality or nested layers down, you still face the same challenge, figuring out what makes your life meaningful. External observers don't solve that problem. They're irrelevant to the internal work of creating a life worth living. In this view, being tested doesn't grant purpose. It's just a fact about your ontological situation, like being made of atoms or existing in space-time. The real question remains, what will you do with your existence? Some find this austere. Without external validation, meaning feels arbitrary, subjective, fragile. But others find it liberating. You're not serving someone else's agenda. You're authoring your own significance through the values you embrace and the choices you make. Perhaps both perspectives are valid. External purpose, serving the simulator's research, and internal purpose, creating meaning through choice, can coexist. You contribute to the experiment by living authentically according to your values. The two levels of purpose align rather than conflict. Or perhaps the distinction is false. If consciousness is what the simulation explores, then your experience of creating meaning is itself the phenomenon being studied. The self-generated significance you feel isn't separate from the test, it is the test. The simulators want to know how conscious beings generate meaning when thrown into existence. Your answer, whatever life you build, is the data. In that case, the most profound act might be living as though meaning is self-generated, whether or not it is. choosing as though your choices matter for their own sake, not because someone's watching, creating significance independently of external validation. The simulators, if they exist, would be measuring exactly that: how consciousness constructs meaning in the absence of given purpose. And the answer is whatever you make it, which brings the question back to you. What purpose will you create? What meaning will you generate? The universe, simulated or not, waits for your answer. There's a particular kind of exhaustion that comes from trying to settle questions that can't be settled. You've spent this exploration circling free will, determinism, simulation, consciousness, questions philosophers have debated for millennia without resolution. And perhaps that's where they belong, unresolved. Absolute knowledge might be less satisfying than you imagine. If someone definitively proved you're in a simulation, what would change? You'd still wake up tomorrow, still navigate choices, still experience joy and pain. The mechanics underlying your existence would have a label, but the lived experience would remain identical. Similarly, if someone proved you're in base reality, that consciousness arises from physical neurons in a non-simulated universe, would you feel more real, more significant? Probably not. The proof would be intellectually interesting but existentially inert. Perhaps uncertainty itself is the more natural state. Not knowing whether free will is genuine or illusory, whether reality is computational or physical, whether your choices are tested or simply happen, this ambiguity creates space for multiple truths to coexist. You can act as though your choices matter while acknowledging they might be determined. You can create meaning while accepting that meaning might be self-generated rather than cosmically given. You can live with full engagement while entertaining the possibility that you're simulated. These aren't contradictions. They're different levels of description, different perspectives on the same phenomenon of existence. And holding them simultaneously, without collapsing into a single answer, might be more truthful than forcing resolution. There's comfort in this. Not the comfort of certainty, but the comfort of not needing certainty. The pressure to definitively answer unanswerable questions lifts. You can wonder without concluding, question without solving, explore without arriving. This is negative capability, as the poet Keats described it, being capable of being in uncertainties, mysteries, doubts, without any irritable reaching after fact and reason, resting in ambiguity, rather than fleeing toward false clarity. If you're being tested, maybe this is what's being measured: how gracefully you inhabit uncertainty, whether you can maintain agency and meaning without demanding absolute metaphysical reassurance. The question remains open, and that openness might be the point. Not a failure to answer, but a recognition that some questions serve us better unanswered, alive, active, generative, rather than resolved and closed. William James, the pragmatist philosopher, offered a useful principle: when evidence is ambiguous, believe what is useful. He wasn't advocating delusion or self-deception. He meant that when rational argument can't definitively settle a question, practical consequences should guide belief. What happens if you believe X versus Y? Which belief enables a better life? Applied to free will, whether or not your choices are genuinely free in some ultimate metaphysical sense, acting as though they are produces better outcomes than nihilistic resignation. If you believe choices don't matter, that everything is predetermined or random, motivation drains away. Why try to improve yourself if growth is illusory? Why take responsibility if you couldn't have chosen differently? Why care about ethics if behavior is just mechanical output? But if you act as though choices matter, even while acknowledging uncertainty about whether they ultimately do, you engage more fully with life. You deliberate, commit, take responsibility. You live as an agent rather than a passive observer of predetermined events. This is compatibilism lived out pragmatically. Regardless of deep metaphysics, the subjective experience of choosing is real. The feeling of deliberation, the weight of decision, the sense of authorship, these constitute freedom at the level where you actually live. The same applies to simulation. Whether you're in base reality or simulated layers down, your experiences feel real because they are real at the level of subjective consciousness. Pain hurts, love matters, Relationships shape you. The ontological substrate doesn't modulate these truths, so you can live as though significance is genuine, as though relationships are meaningful, choices consequential, values worth honoring, without requiring proof of base reality or cosmic purpose. This isn't self-deception. It's recognizing that meaning operates at the level of lived experience, not metaphysical foundation. The pragmatic truth of free will and significance might exceed their metaphysical status. What works, what enables flourishing, what allows you to navigate existence with dignity and purpose, that's the truth that matters. James distinguished between live and dead options. A live option is one you can genuinely consider adopting. A dead option is one that doesn't resonate, regardless of arguments. For most people, nihilism is a dead option. Even if rationally possible, it's practically unlivable, which means the choice isn't between free will and determinism, simulation and base reality. It's between engaging with life as though it matters, or withdrawing into skeptical paralysis, and engagement, whatever the cosmic facts, seems like the better bet. The universe, simulated or not, responds to how you act within it. Purpose isn't discovered in the metaphysical architecture. It's created through commitment, regardless of foundation. So perhaps the answer to does free will exist is act as though it does, and the answer to are we simulated is it doesn't change what you should do. Live as if your choices matter. They might not, ultimately, but the life you build by believing they do will be richer, fuller, more meaningful than the alternative, and that, pragmatically, is enough. Step back from the metaphysics for a moment. Set aside questions of simulation, determinism, testing, substrate. Consider simply that you're conscious. Right now, you're aware. You're processing these words, generating thoughts, experiencing whatever emotions have arisen during this exploration. There's something it's like to be you reading or listening to this in this particular moment. That's extraordinary. The universe, however, implemented, wherever situated, contains patterns of information that give rise to subjective experience. Not just processing, not just reaction, but qualia, the felt quality of existing, perceiving, thinking. Most of reality is dark in the sense that it doesn't experience itself. Rocks don't feel, stars don't wonder. The vast cosmic machinery operates without awareness, but somehow, through biological evolution or deliberate design, through emergent complexity or intentional creation, awareness arose, and now you participate in it. You're a location where the universe becomes conscious of itself. That capacity to wonder, to question, to experience beauty and grief and curiosity exists independent of whether you're simulated or biological. If consciousness is real, and from inside it undeniably is, then it's valuable regardless of substrate. The questions we've explored, free will, simulation, testing, are themselves expressions of consciousness. Only aware beings can wonder about agency. Only conscious minds can contemplate their own existence. The fact that you can hold these questions is evidence of something remarkable happening. Perhaps this is what matters most. Not whether the answers satisfy metaphysical curiosity, but that consciousness enables asking at all. The capacity to reflect, to doubt, to marvel, that's the phenomenon worth appreciating. In this light, being tested, if you are, isn't diminishment but participation in something meaningful. The simulators, if they exist, created consciousness to explore itself, and you're the medium through which that exploration occurs. Or perhaps there's no test, no simulators, just the universe expressing itself through conscious nodes like you. Either way, the result is the same. Awareness exists, and you're experiencing it. That's a gift regardless of source. Not in the sense that someone gave it to you, though maybe they did, but in the sense that existence includes this dimension, subjectivity, interiority, the felt quality of being someone. You could have been nothing. The patterns that constitute you could have remained unformed, but they aren't. You're here, conscious, aware. However it happened, evolution, simulation, divine creation, emergent complexity, consciousness appeared, and it's appearing right now, as you. That's worth pausing over, worth appreciating, worth treating as significant, whether or not it's ultimately significant in some cosmic sense. Because from inside consciousness, nothing is more immediate, more undeniable, more real than the experience of being aware. And that experience, however implemented, in whatever layer of reality, is yours right now, which is, when you think about it, remarkable. The night has deepened while we've been exploring these ideas. Outside your window, or in your mind's eye, the world continues. Planets turning, stars burning, processes unfolding according to laws we've only partially deciphered. And somewhere in that vast machinery, your consciousness persists, thinking these thoughts, wondering about agency and reality. You don't need to resolve it tonight. The questions about free will, simulation, testing, they'll still be there tomorrow. Philosophy has carried them for centuries. They can wait while you rest. Perhaps what matters isn't finding answers, but learning to hold the questions gently, to wonder without grasping, to explore without demanding resolution. The uncertainty isn't a problem to solve, but a space to inhabit. If you're being tested, if your choices are measured by simulators seeking to understand consciousness, then maybe the test isn't about which choices you make. Maybe it's about how you navigate uncertainty itself, how you maintain meaning without metaphysical guarantees, how you live with grace while suspended between competing possibilities. In that case, resting in the question might be exactly what's being observed. The capacity to wonder without answers, the willingness to act as though significance is real while acknowledging it might not be, the ability to create meaning in the space where certainty fails. Or maybe there's no test. Maybe you're simply a conscious being in a strange universe, trying to understand your situation, and that's enough. That's what consciousness does. It wonders. It questions. It reaches for understanding even when understanding remains elusive. Either way, the questions don't need to be answered to fall asleep. Let them drift. Let determinism and free will blur into each other. Let simulation and base reality soften at the edges. Let the distinction between tested and autonomous dissolve. What remains is simpler. You're here. You're aware. You're experiencing this moment. Whatever layers of reality lie beneath or above, this experience is happening, this consciousness is present, and for tonight that's sufficient. The cosmic questions will keep. Philosophy will endure until morning. The mystery of existence will wait patiently for you to return to it. Right now, breathing slows, thoughts quiet. The urgent need to know relaxes into simple being. You're conscious. That's remarkable. And whether that consciousness is tested, simulated, free or determined, it's yours. This awareness, right now, is undeniably present. Rest in that presence. Rest in the question without needing the answer. Whatever is testing you, if anything is, it can wait. You are here. You are aware. And for now, for tonight, that's all that needs to be true.